Great. So this was question 5. At a certain resort, the number of hours of sunshine measured to the nearest hour was recorded on each of 21 days. The results are summarised in the table. The diagram shows part of a histogram to illustrate the data. The scale on the frequency density axis is 2 centimetres to 1 unit. And then it says calculate the frequency density of the 1 to 3 class. Okay. So remember, the first thing that we need to think about is we need to think about what is the width. We need to be really careful about our boundaries of each of our classes. So the key thing here, we're told that this question, we're measured to the nearest hour. So these figures 1 to 3 are to the nearest hour. So that actually means 0.5 to 3.5. So the class that we're dealing with is 0.5 up to 3.5. So the class of that, the class width of that is 3. 3.5 take away 0.5. The width equals 3. Remember what we just said, that the frequency density multiplied by the width has got to give us the frequency. So I'm just going to scroll down here to do this. So for part 1, this is equal to the frequency divided by the width. So we need to do frequency of 6. We maybe need to align the board again. Frequency of 6 divided by a width of 3. So for 1 mark we've got a frequency density of 2. Fred wishes to draw the block for the 10 to 15 class on the same diagram. Calculate the height in centimetres of this block. Well, it's kind of a similar question, isn't it? It's asking us for the frequency density first. So let's go through that bit. So for part B, we now have a class that is 10 to 15. So that is 9.5 up to 15.5. So the important thing to get from this is actually that the class width this time is 6. Notice how easy it is to blunder into a mistake with this, to just think 10 to 15, 15 take 10 is 5, so that's the width. Whereas you've got to look at the upper and lower class boundaries. Right, what else have we got? We've got that we need to find the frequency density, which is the frequency divided by the width, so that is going to be 2 divided by 6. So we have a frequency density of 1/3, but here's the little trick in this one. They did say the scale on the frequency density axis is 2 centimetres to 1 unit. So it's 2 centimetres to 1 unit. So the height is going to be 2 lots of 1/3. So the height is going to be 2/3 centimetres. That's our answer for that bit. That was a bit mean, throwing in that thing about converting it to centimetres in that one. Part 2, a cumulative frequency graph is to be drawn. Write down the coordinates of the first 2 points that should be plotted. You are not asked to draw the graph. Right, now we haven't talked about this bit.
No.
So this what's the space in A104?
104.
A104, yeah.
Okay.
Sorry, video rolled. So what we think about cumulative frequency, first thing to remember, you always need to start your cumulative frequency graph. I'm not in the video. Oh, okay. I'm not in the video now. Thanks, Emily.
Sorry.
Maybe we'll move it around for the next one. Right, what was I saying? Oh yeah, you always have to start your cumulative frequency graph from the x-axis, from the horizontal axis. So the first thing that we really ought to remember is our first boundary. Well, what's the figure that there are none below? looking at our data there, is that first group is 0.5 up to 3.5, isn't it? So there are none of them below 0.5. So we should really draw our first point at 0.5 on the x-axis and 0 on the y-axis. So part 2, 0.50. The next point that we need to draw is at the end of that first group. Now that first group goes up to 3.5, that's the upper boundary of that group, and we've got a total of 6. So the next point is at 3.5 and 6. And did it say the first 2 or the first 3? I've done the first 3 for this. Okay, well I think that would probably be enough at that point. What would be the next one? What would be the next point? Can I cumulative frequency graph? It's very quiet. Come on, Joe.
6.59.
Would it be 6.59? It would be 6.5, but it's cumulative frequency, isn't it? So we're adding on as we go along. So the next point would be 6.5. And then 15, because you're adding on the next point. I didn't actually ask it for that, did it? But I've done it anyway. Now, calculate estimates of the mean and standard deviation for the number of hours of sunshine. Explain why your answers are only estimates. Right, so actually we've gone on, haven't we, into the next section of this, which is about measures of location, talking about mean, median and mode, and finding estimates of the mean and standard deviation. Well, I did this. This was the last thing we did before we moved away from doing S1 in September. I would draw out another little table. Do you want to head down to A104? We need the midpoints of each of our groups. Now the midpoints, we can make this complicated or easy. You can think you could add together the upper and lower boundaries and divide by 2, but actually because we're kind of going either side half away, it doesn't make any difference whether we just use those or the numbers that are there. So our midpoints are going to be 2 and 5 and 8 and, what's that, 12.5. So we need a little table of values for this. I did, when I was working this out, draw a little table. I've got my x values for my midpoints as being 2, 5, 8 and 12.5. The frequencies were given in that table as being 6, 9, 4 and 2. Now let's think what we're needing here. We're needing the mean and the standard deviation. So we need x times f, or an fx column, for multiplying these together. What we're doing there is we're saying there were 6 in this first group, so we'll pretend that all 6 of them were of time 2, and we'll do it that way. So that gives us 12, 45, 32 and 25. And we also need an fx squared column if we're doing the standard deviation. And we're going to be really careful. This does not mean that number squared. It means the frequency times x squared. So that's 6 times 2 squared. So 6 times 4. And this is 9 times 25. I've got these written down, so I'll just write what these are. And this one is 64 times 4, so we get 256 out of that. And then here we've got 12.5 squared times 2, which is actually 312.5. And we need the totals of these. And the important things here are sigma f. Now that's like n. That tells us how many were in our survey. And if we add these up, it's 21. If we add up this column here, sigma fx, then that is 114. And if we add up this column, we come to 817.5. I think I've got these right. There we go. Okay. Now, do we remember what we need for these to do with these figures? The mean is sigma fx over sigma f. So to work out the mean, we've got 114 divided by 21, which was 5.43 to three significant figures. And the standard deviation, and we'll talk about the standard deviation quite a lot this afternoon. There's only really one thing to remember. But in terms of working out from this data, it's going to be the square root. It's that number, sigma fx squared, over sigma f. And then you take away the square of the mean. So we're now going to take away that one squared. So we're doing 817.5 over 21 minus, and let's, just to make sure that we don't get any rounding errors in here, let's use our previous answer. Let's not use the one that we rounded to three significant figures, but let's use the full version of it. And that gives us 3.08. To three significant figures. And the final part of the question said, explain why your answers are only estimates. Well, that came in this bit where we set up the table. Because remember what we did? We took the midpoints of each of those groups in the original table, and what we've done is we've assumed that all 6 of these ones had a value of 2, when actually they were in a group that went from 0.5 up to 3.5, so they were quite widely spread. So how we're going to articulate that, we're going to say that for the final part, the actual values are not known, so we use the midpoints of the classes. There's quite a lot in there, isn't there? And we're just thinking, and we'll think about these things, about how we're going to remember the mean and standard deviation bits. There we go. Stop that video.